Hello friends, in this video, let us discuss about the implementation of finding nth Fibonacci using top-down approach with memoization. So as we have discussed in the previous video, the algorithm to implement the top-down approach with memoization is first declaring an array to store the sub-problem results, then initializing the array to -1. Here, -1 indicates that the sub-problem solution needs to be computed. Now, before making any recursive call, check whether the sub-problem needs to be solved. That is, if it is already solved, we only need to take the result from there. Only otherwise we need to compute it. So check if result of n equal to -1. If yes, it needs to be solved. So compute it and store it in result. Else, if it is already solved, just return the already computed result. Let us see how it works. We are going to find fib of 4. So in this call, n will be equal to 4. Check if result of 4 equal to -1, and it is. So we need to compute the result. Now check if n is less than or equal to 1, and it is not, as n is equal to 4. So else part will be executed. Here, fib of n is equal to fib of n-1 plus fib of n-2. So we have two recursive calls. And here, the first recursive call fib of n-1, that is fib of 3, will be executed first. And the next recursive call fib of n-2 will wait until the first recursive call finishes its job. So fib of 3 will be called, and here first we will check if result of n equal to -1, and it is. So we need to compute the result. So check if n is less than or equal to 1. Since n equal to 3, it fails. So the else part will be executed. And here again we have two recursive calls, fib of n-1, that is fib of 2, and fib of n-2, that is fib of 1. And the first recursive call fib of 2 will be executed first. And the second recursive call fib of 1 will wait until fib of 2 finishes its job. So fib of 2 is called. And here also, first we are checking if result of n is equal to -1. And it is -1. So it means it is not solved yet and we need to compute the result. So check if n is less than or equal to 1. And since n equal to 2, it fails. So the else part will be executed. Here, we have two recursive calls again, fib of n-1 and fib of n-2, that is, fib of 1 and fib of 0. Here also, as we have discussed, the first recursive call fib of 1 will be executed first, and the next recursive call fib of 0 will wait until fib of 1 gets completed. So fib of 1 will be called, and here also we are checking if it is solved, and we have result of 1 is equal to -1. So we need to compute the result. So check if n is less than or equal to 1, and it is. So set result of n equal to n. So in the array, result of 1 is set to 1. Now, whenever we have fib of 1 called, we can simply take the result from this array and we do not need to compute it. Now here we have return result of n. So 1 will be returned to calling function fib of 2. Now this recursive call is finished. It has done its job. So now the second call fib of 0 will be executed here. Here also, first we are checking if it is solved. And we have result of 0 equal to -1, so we need to compute the result. So check if n is less than or equal to 1, and it is. So set result of n is equal to n. So in the array, result of 0 is set to 0. And here we have return result of n. So 0 will be returned to the calling function fib of 2. Now this recursive call is finished. And here we have result of 2 equal to fib of 1 plus fib of 0, that is 1 plus 0, which is equal to 1. So result of 2 is computed and we got 1 and it is stored in the array. Now we have return result of n. So 1 is returned to the calling function fib of 3. Here, the first recursive call is finished. Now the second one will be called, that is fib of 1. So it is called and here first we check if result of n is equal to -1. But it is not, which means this sub-problem is already solved. So we can just visit the array and take the result from there and return it. So this if block will not be executed and the next statement return result of n will be executed. So 1 is returned to the calling function fib of 3 and this call is completed now. So here in fib of 3 we have result of 3 computed which is 1 plus 1 which is equal to 2 and it is stored in the array. And finally we have return result of n. So result of 3 that is 2 is returned to the calling function fib of 4 and here first recursive call fib of 3 is completed. Now the second call fib of n-2 that is fib of 2 is called. Here first we check if result of n is -1 but it is not, which means this sub-problem is already solved. So we can just visit the array and the already solved result will be returned. This will save a lot of time and space in computing the result. If we had to compute it again, we have to check if n is less than or equal to 1 and if it is not, there will be 2 recursive calls and it will take a lot of time and space. So this is how memoization makes the program efficient. So here, this if block will not be executed and the next statement return result of n will be executed and 1 will be returned to the calling function fib of 4. And this call is also completed now. And in fib of 4, we have result of 4 equal to fib of 3 that is 2 plus fib of 2 that is 1 which is equal to 3. And finally, result of 4 is returned to the calling function. Thus, we have got the result fib of 4 equal to 3. And this is how, in top-down approach, memoization helps us avoid the recomputation issue and saves a lot of time and space.